Question 1. Mu is the value for x is 7. The Poisson formula, P of x, is mu to the x e to the minus mu over x factorial. They want us to compute P of 7. This becomes 4 to the 7 e to the minus 4th power over 7 factorial. 4 raised to the 7th times our exponential number. Use the minus, the negative sign here for your power, because the power is negative. Don't use a subtraction symbol. Use the negative sign. Divide by 7. We need the factorial. PRB, factorial key. Hit enter. The numbers we see here has a 5 in the 10,000ths position. So the digit to the right is a 4, which means the 5 is unchanged. The answer is 0.0595. And you're done. Question 3. Question 3 says that there is a mean amount of failures per day of 0.21 failures in a day. If x is the number of failures in a day period, question 3 wants us to determine the probability there's exactly 2 failures in that day interval. Using the Poisson formula of mu to the x e to the minus mu over x factorial, we are going to have to compute P of 2 with the mu of 0.21. Ladies and gentlemen, 2 factorial is the value 2. Sometimes it's easier to perform a computation with our calculator if we know some of these factorial values. E, the exponential number, to the negative 0.21 power divided by 2. The 8 is in the 10,000ths position. The digit to the right is a 7, which means add 1 to 8 to make it a 9. The answer is 0.0179. Question 5. Question 5 indicates that there was a mean of 2.2 whales arriving in a day interval. If x is the number of whales that arrive in a day interval, question 5 wants to know what's the probability that 5 whales arrive in a particular day. The Poisson formula is mu to the x e to the minus mu over x factorial. We have to determine P of 5. Let's see what this is approximately. 2.2 raised to the 5th power times my exponential number to the minus 5th power, to the minus 2.2 power, divided by 5 factorial. The 5 is in the 10,000s position. The digit to the right is an 8, which means to add 1 to 5, making this a 6. The answer is 0.0476. Question 7. Question 7 indicates that there is an average of 0.8 defects per square foot. They want to know if you let x be the number of defects per square foot, they want to know the probability of finding more than one defect. They want to know probability of finding 2 or 3 or 4 or 5 or 6, and this goes on forever. The most efficient way to answer this question would be simply to use the complement rule and take 1 minus the probability of the outcomes that are not there, like p of 0 and p of 1. So if we compute these probabilities for the outcomes that are not there, we will subtract these values from 1. Using the Poisson probability formula, with x being 0 and 1 and mu being 0.8, we can perform these calculations. P of 0, 0.8 to the 0, e to the minus 0.8 over 0 factorial. Any base to the 0 power is 1, and 0 factorial is 1, which means that p of 0 is really e to the minus 0.8. Our exponential number, e to the negative 0.8th power. Approximating this number to the nearest 10,000ths, the 3 is in the 10,000ths position. The digit to the right is a 2, so the number is actually 0.4493. This is p of 0. P of 1 becomes mu 0.8 to the first power, e to the minus 0.8th power, over 1 factorial. The value of 1 factorial is 1, so this becomes simply 0.8 to the first power, or 0.8, times e to the minus 0.08 power. Since we already have e to the minus 0.8 power, let's multiply that answer by 0.8. The 4 is in the 10,000ths position, which means the digit to the right is a 6, indicates that we must add 1 to 4, bringing the approximate value to be 0.3595. Recall, we are determining the probability that there is more than one defect, which is 1 minus the probability there are no defects, minus the probability there is one defect, all by using the complement rule. So, if we take 1 and we subtract 0.4493 minus 0.3595, we get the answer to be approximately 0.1912. Question 9. Question 9 gives us a mean of 21.6 calls per day. A day is 24 hours. The probability question they want us to answer is, what's the probability of getting a call, or one call? Now, X is the number of calls, but they want to know the probability of getting a call in 1 hour as opposed to 24 hours. In other words, X is 1 for an hour time interval. We have to find a new value of mu. We know mu is 21.6 calls in a day, which is 24 hours. So 21.6 to 24 hours is the same as some new mu value to 1 hour. These are two ratios. The key is to create a proportion. That's 21.6 calls per 24 hours is the same as some new mu call to 1 hour. Mu number of calls. Now, any value divided by 1 is itself, so that mu is going to be 21.6 over 24, or we really say mu is going to be the value of 0.9. There is going to be 0.9 calls per hour. So, using our Poisson probability formula, that P of x is mu to the x, e to the minus mu over x factorial, where x is the value of 1 and this mu is 0.9. Again, 1 factorial is 1, so this becomes 0.9 e to the minus 0.9. Let's see what we get. Your exponential number to the negative 0.9 power. Now, the 9 is in the 10,000ths position. The digit to the right is a 1. That means we do not change our 9. And the answer is 0.3659.